Thank you for clicking on the help video. So on this homework problem, we're asked to describe the end behavior to the following functions. So I'm going to go through 4 examples here so you know what to determine, again, how to determine the direction that the graph is going to look. Now, again, the key thing is to focus only on the leading coefficient. So we're going to use, yet again, like I explained in our lesson today, using the leading coefficient or leading term test, okay? Which simply means that we're going to only focus on the first term to each polynomial. All the other terms are irrelevant, so we could ignore what we're doing there. So the end behavior, again, depends on 2 things. First, whether the leading term is positive or negative, and second, whether that leading term has an even or odd degree. So let's look at the first example, A. Since this number right here is a negative value, that tells us that the right side is going to decrease and that the right side is going to fall. Now, to determine how the left side is affected, we look at the degree of this. If the degree is an odd number like this, 7 is an odd number, then the right side is going to move in the opposite direction of whatever the left side. The left side is going to move in the opposite direction of whatever the right side is moving. So since the right side is falling, the opposite of falling is rising. So the left side is going to rise. So that's the end behavior of the first one. Now let's say that this number was, instead of a negative number, it was a positive number. Whether that positive number is 8 or 1, this value right here is positive. So how that's going to affect the end behavior? Well, it affects the end behavior with the right side, instead of falling, it now rises. It's going to now move upwards. And well, how's the left side going to move? Well, again, because this number is an odd number, it could have been 5, it could have been 3, it could have been 9, but as long as it's odd, that means that the left side is going to move in the opposite direction of the right. So in this scenario, since the right is moving up, the left is now going to move down. And we're going to say that it falls. So now let's look at the other 2 examples, example C and D. Well, similarly to example A, letter C, let me write this down first. Letter C is going to have the right side again going downwards, falling. And again, the reason for that, because that leading coefficient here is a negative number. So with this being a negative, -6 specifically, that's going to affect, again, the right side is going to go down, just like example A and example B. Well, what's going to happen now to the left? Well, in this example, because the left side is an odd number, okay, I'm sorry, this is now an even number. The left side is going to go in the same direction as the right. So since the right is pointing down, the left is also going to point down. So it's also going to fall. So let's look at the last example. Change this to an 8. That should not be a 7, because then it's going to do the same thing as one of the previous ones. Then that's going to be the same thing as this one. It's going to have the same behavior as that, as letter B, because it's essentially the same thing. The only difference is that this is a 9 and a positive 8. So with this being a positive 9 and being a positive 8, the right side is going to look the same. And with this being an odd number, the left side is going to go in the opposite direction. But let's do this instead. Let's have the exponent, instead of being a 7, let it be an 8 instead. So let's say it's 9x to the 8th power. So let's talk about the end behaviors here. So for this example here, the end behavior, since this is a positive number, since our leading term has a leading coefficient of a positive 9, then that means that the right side is going to go up and it's going to rise. Just like in example B. This was a positive number, this is a positive number, so the right side is moving up. Now, what's going to happen on the left? Well, similar to example C, since this is an even number, that means that the left side is going to move in the exact same direction as the right. So this is going to point downwards as well. So you see, the first term determines again the end behavior of our function by doing exactly that. I always start by first focusing on the right term first and thinking about this as the slope of a line. Like if you were just analyzing lines and we had negative x plus some number, knowing that this is a negative tells me that the graph is going to move, that the line will move downwards. And that's exactly how the right side moves. If we had a line where the slope was a positive 8x plus again some y-intercept, we'll call it b. Again, this right here tells me that I'm going to have a line that it's increasing. So that's exactly what the right side is doing. And then for the left side, well, just on the degree. Odd, think about opposite. So the left side is going to move in the opposite direction as whatever the right is. And even for same. Okay, doesn't correlate that well, but it's going to do the same thing as the right. So if my right rises, it should be the same. Why am I doing this the opposite direction? Sorry. That should also be going up because it's an even. So this should be doing the same thing as the right. So it should be moving upwards also. Sorry about that. I made a mistake. And I'm glad I caught it before I ended the video. Well, hopefully this is helpful, and I appreciate you watching.